drafting website, although I'd be much wealthier if it were mine. Thank you very much, Mr. Chairman. For Dr. Chang and Ms. Benzel, both of you had talked about the need to create a science of cybersecurity. And if you can elaborate a little bit on that, what are the metrics we would need? If we don't know right now if a company is more secure than it was a month ago, where do we even start with this? What sort of research do we need? What sort of metrics do we need to develop so we even know what we're talking about?
Well, that's one of the key issues. We actually don't have the right language, the right set of metrics to even begin to understand, you know, this notion of whether the computer this year is more secure than it was last year. This computer is more secure than somebody else's. There's kind of this idea of understanding the limits of what's possible. So that's what a science allows you to do. Can I understand, you know, how secure something can be? We sort of don't know kind of what's possible, you know, what are kind of the control bounds. Cybersecurity is an adversarial science, and like anything adversarial, we'll probably never completely eliminate it. But if we can establish some sort of control bars that basically say, we're going to make it harder for an adversary to kind of get through, and maybe the difficulty that if we make it too hard for them to get through, then they'll quit trying. But it's this notion of kind of setting some control bars and trying to keep it within that. We certainly won't eliminate crime.
So we advocate being able to do experimental science. So in many other sciences, we have workbenches and labs, and we can go in, and we can also repeat our peers' experiments and be able to understand what they are. Unfortunately, in computer science, and in particularly in cybersecurity, the experiments are very ad hoc. And so it might work once, or it might work in my lab or in my example. This is one of the challenges also in technology transfer. It may have worked in some researcher's lab under some conditions, but I don't know that it's really going to work. So what we really advocate is that we need an experimental science where we can create hypotheses, we can do an experiment, see the results, modify some parameters, rerun the experiment, and my colleagues similarly have an opportunity to do that just as they would in any of the hard sciences.
Are there any of the federal agencies that are actually doing work on this notion of the metrics that we would even use to measure? I'm aware of some work that has started at NIST, and I would tell you I haven't looked at the work in more detail. I probably need to, but I'm recalling from some years ago, maybe 2009, 2010, within the Computer Security Division at NIST, they started up a program in metrics. It's something I would need to look at further, but I believe there is some activity happening.
Metrics is a very difficult area in security and has plagued us for a long time. I would say that DARPA has started some work there and some very fundamental research. The National Science Foundation and DHS S&T always include metrics as a research topic in their calls.
And one final question. As I know some colleagues and friends of my son who's a junior in college, if you could elaborate a little bit more on this adversarial science notion, because I think it is different. It strikes me as different than a lot of times what attracts people to science in a sense of the purity and how you go about thinking about recruiting young people, designing programs, if they need to have this back and forth adversarial approach.
I'd have to do some more thinking about this, but the models of the human immune system strike me as a reasonable model. So basically the human immune system is fighting off adversaries of all kinds, and it's just, you know, sort of amazing how versatile and how flexible the human immune system is. The human immune system, but by the way, about 1% of human cells or leukocytes are actually defensive. So when you think about, you know, the body is basically allocating about 1% of its cells to defense, that's a pretty substantial number. If you looked at the number of lines of computer code, I doubt 1% is dedicated to defense. The other model that seems to make sense to me in terms of a science is in the field of actually agriculture. So agriculture also has pests, and the pests try to eat the crops. And you can either make the crops more resilient or you kill the pests. I mean, that's another sort of adversarial model that seems to be relevant.